The magnitude of a vector is the actual length of the vector, that is, the distance from the beginning of a vector to the end as measured with a ruler. We denote this by using the word magnitude or by drawing vertical lines either side of the vector, as here. As the x component and the y component are at right angles to each other, finding the magnitude of a vector normally involves a simple bit of Pythagoras' theorem. Take this simple situation. The point A has coordinates 3, 4 and the point B has coordinates 7, 15. So the question is, what is the magnitude of the vector AB? The vector AB isn't difficult to find. It's simply 4 units to the right and 11 units upwards, i.e. 4 over 11. Drawing in a right angle triangle and calculating the hypotenuse, we find the magnitude of vector AB is the square root of 4 squared plus 11 squared, i.e. the square root of 137, which is roughly 11.7046999, etc. or 11.7 correct to 3 significant figures. So we can write this as AB, that's with a line either side, equals 11.7 correct to 3 significant figures, or we could write the magnitude of AB, vector AB, is 11.7 correct to 3 significant figures. These two ways are equivalent. Now, it doesn't matter if the coordinates of the points defining the vector are negative, as when we square them, they'll always become positive. In other words, the magnitude of a vector is always positive, or perhaps 0 if we're dealing with the 0 vector. Magnitudes of vectors are never negative. Take this slightly harder example. Point C is minus 4, 9, and point D is minus 6, minus 15. So the vector CD is minus 2 over minus 24. We use Pythagoras' theorem to find the magnitude. So the magnitude of the vector CD is the square root of minus 2 squared plus minus 24 squared, which is the square root of 4 plus 576. And it's at this point, of course, that everything becomes positive. That's equal to the square root of 580, which is approximately 24.083, and that is 24.1, correct to 3 significant figures. And that's all there is to it, really. Don't you wish everything was that simple?